Well, hello, pre-calculus students and seekers of general truths. In this video, we will continue our study of annuities and the mathematics of finance, and we will extrapolate what we've learned so far to the general case. So, if you recall up to this point, we have an example of Jack investing $500 every quarter, right, for 5 years, so that's a total of 20 quarters. We did all this work and we got this answer. Now, what about the general case? What if this was a different rate and a different amount and a different time, and we compounded, 12 times per year instead of 4 times per year and all that. So I'd like to just start off with a recap of how we got to this point to begin with, and I've just copied the answer from the last line from the previous work here. And let's try to extrapolate this. Okay, so if we're investing our dollars every period, so this 500 here is our replacement for R. Right, so Jack was investing $500 every quarter, right? K times per year, so that's like the compound time, and that's where that K affects a couple of different things. It affects this 20, right? This 20 here is really K times T. And again, if we look back at the previous problem, we got 20 because Jack was investing for 5 years quarterly. Okay? So he was investing 5 years quarterly. That's how we got to this 20. It's really 5 times 4. 4 times per year for 5 years. All right. Now the other part of this is also important. This term right here and this term right here, where does that come from? Well, let's look all the way back at the problem number 1, that he was investing 6% interest. So this is 1 plus 6% divided by 4. That's how we got 1.015. So just to be clear, 1 plus 0.06 over 4, that's equal to 1.015. So returning to our general case now, okay, this expression here, the 1.015, that's really 1 plus the rate that we're compounding, that we're calculating, divided by the number of times we're compounding per year. So that's really 1 plus 1 over R. Okay? So if we kind of like break down the anatomy of this equation, this is what we get in the general case. So let's put it all together. It would be big R multiplied by 1 minus 1 plus R, little r, over K raised to the KT, and all of that divided by 1 minus 1 plus R over K. All right, so make sure you can maybe pause the video, process this, and make sure you understand where all these pieces are coming from. And this has a special name. This is called the future value of an annuity. It's a very important formula in the world of finance. We abbreviate it often FVA. All right. And just to get a little bit of practice, let's do a couple more of these. So let's say that we had $300 invested at a 7% rate for 6 years, paid quarterly. How would we calculate that? Well, that's big R, right? So that's 300 multiplied by 1 minus 1 plus 0.7, that's our interest rate, paid quarterly, so over 4, raised to the 4 times 6, because we're doing this for 6 years. All of that divided by 1 minus 1 plus 0.07 over 4. Okay? And if you type this carefully into your calculator, we should get approximately $8,853.30. So that's for the case of $300 being invested at 7% every single quarter for a period of 6 years. Similarly, we can do something like that with a different case here. If we had 600, so that's big R, investing at a 4% interest rate, so 0.04 over 12 this time because it's being paid monthly, so 12 times per year, raised to the 12 times 5, period of 5 years. All of this divided by 1 minus 1 plus the interest rate divided by the compounding, the number of times compounded per year. And again, be very careful typing this into a calculator. Our final answer is going to be approximately $39,779.39. So we do need a little bit of practice. I think you do need a little bit of practice just typing this into a calculator. And also, if you know and remember how to program a calculator, this formula is a fine candidate for doing that. All right, so we've made it now from the small case of an annuity to the bigger scenario of 5 years to the general case, and we got this nice formula. As always, keep working hard. Ask for questions if you need it. Thank you for watching and have a wonderful day.